Good morning, everyone. We're going to, let's see. So yesterday, you guys were doing the asynchronous assignment, going through the notes worksheet, practicing through differential equations, and hopefully the video that I provided offers some support, offers some help in helping you getting through it. So I updated the class calendar on the website. Just wanted to kind of go over a couple of things that the schedule next week is going to be the same, but the week after is what I want you guys to be aware of. So we're going to go through our test review number 1 today. But the homework for worksheet, homework number 6, I'm going to do a help session this afternoon at 3:30. Going over worksheet homework number 6, and if I have time, maybe I'll go over homework number 5 as well. But it'll be recorded, so if you can't make it, you can always have access to that video. I'll put a link to it under today's date. Monday, we'll do test review worksheet 2, and our focus is just on Riemann sums and differential equations. So we'll go through that Monday as well. There's a test review homework that I'll do help session 3:30 Monday as well. And then Tuesday will be your Riemann sums differential equation test. Okay, it'll just be pretty much the same length as your FRQ that you took, FRQ quiz that you took from before, where just front page and back page. But now it's going to be 2 separate topics here. I'll have a morning review at 7:15, and then you'll take the test in class on Tuesday. Okay. Wednesday, and then after we get through this FRQ, we'll shift our focus to multiple choice. Okay, so we'll have multiple choice review on Wednesday, Thursday, and Friday. I'll probably kind of focus our attention on kind of split up into maybe 3 or 4 separate categories where I can take care of the first semester material Wednesday, Thursday, and then second semester material Friday and Monday. Initially, I had the multiple choice test being on Tuesday, but I forgot that the 26th to 30th this week is all EOC week. So what that means is there's going to be testing that needs to go on the first 2 hours of the day, or maybe more. So like 8:30 to 10:30, maybe 11. So that means bell schedule isn't going to begin until like 10:30 or 11, and each class is going to be shortened significantly. So we're not going to have a full period on Tuesday. So what I'm going to do is I'm going to split up that multiple choice test into 2 separate days. So we'll do a 30-minute portion on Wednesday, multiple choice numbers 1 through 8, and the multiple choice questions 9 through 16 will be on Thursday. Yeah, and I think these are going to be the 2 best days out of the week because we're going to have more time during these 2 days than the other days. Tuesday and Friday, these are both longer EOCs, so that's going to significantly cut the period schedule even more than these other days. And also, there's no advisement, no SEL on the 28th, so we guarantee that we're going to at least get that 30 minutes per class period. Okay. We'll do some more miscellaneous review on Friday. Monday, do miscellaneous review, and then Tuesday is going to be your AP exam for those of you who are taking it face-to-face or taking the paper exam here at school in the gym. Okay. Now, along the way, you also have assignments that are due. So the first set of assignments is going to be due next Wednesday, assignments 1 through 5. So assignment 1 started with that Friday before the break, differential equation and volume, FRQ and worksheet. That's the first assignment. And then assignment 2 was Monday, assignment 3, 4, 5. So basically, assignments 1 through 5, which assignment 5 was yesterday, so you have a couple of days and the weekend to get that ready so they can turn it in by Wednesday. If you turn in early, great, but you have until next Wednesday to turn that in. Okay, and then the following Wednesday, assignments 6 through 10 will be due. And then initially I had assignments 11 through 16 due that Wednesday after the AP exam. But because all these are shortened weeks and we may have less time to do these worksheets, I'm going to extend that out to Friday. Okay. Assignments 11 through 16. I don't want to push this any further than this date because I want to have the weekend to get all the grades ready. I know that soon after this, senior grades will be due, so I want to have the weekend to resolve any, finalize grades, especially for seniors. Okay. But once again, you can turn in all these assignments late and you can still earn the majority of the points. Okay.
Wait, we're still going beach, right?
Mm-hmm.
Okay.
If you take me.
Yes. Fine. And then I will go to Southern.
How long do we get to the beach?
Yes.
Okay, so now out of, I want to talk about the point total for these assignments here. This is all going to go in as a 200-point test grade. So first up is this FRQ, which is 50 points. The test is 50 points as well, but split up into 2 separate days. It's 25 points each. So that's 50 points, that's 50 points, that's 100 points there. And then the other 100 points comes from all these assignments that you're turning in, assignments 1 through 16. So they're all going to go in as one test grade, which means that your homework grade is going to act as a buffer for your test grade. So that's kind of acting as your quote unquote your curve, right? So yeah, there's one more grade remaining in the grade book, which is this 200-point test grade, and these are the components of that test grade. Okay, any questions? Oh, and also when you're turning in your assignments, feel free to take photos. If there's a limit in terms of number of photos that can go, that you can put into that team's assignment, you're welcome to take photos 2 pages at a time. And if they're out of order, that's fine, right? Because I know that front and back, you're not going to be able to get both pages on the same photo, but if you can kind of stack them in a way where you can get all 10 pages or all 20 pages within 10 photos, that's perfectly fine. Okay, any questions with the calendar, with the schedule, with the exam? Yes.
Is that EOC schedule available?
Not yet, not yet. They shared a draft version with the teachers, but then Mr. Jones said to not share it because it's still not finalized. So when it is finalized, I think they're going to share it with the community, and I think you'll see it in the email or on the website as well, on Milton's website once it's finalized. Okay. All right, let's go to today's worksheet. All right, let's read through this first problem here. It says a large vat is initially filled with saltwater solution. A solution with a higher concentration of salt flows in the vat and solution flows out of the vat at the same rate. The number of pounds of salt in the vat at time t minutes is modeled by the function a that satisfies the differential equation dA dt. At time t equals 10 minutes, the vat contains 50 pounds of salt. So part A says write an equation of the line tangent to the graph of A at t equals 10. So first things first, tangent line equation. And that means we need to identify order pair, we need to identify slope, point slope form. And then from there, we can do the linear approximation, which is the second part of part A. But let's see, we need to find order pair first. Now, order pair, I know typically we're used to seeing x's and y's. But in this case, looks like our order pair is going to be given to us in a different set of variables. So instead of x and y, we're going to have t for time and a for the amount of salt. So just have to make that slight adjustment there. Now, if you ever have order pair that's not in terms of x and y, it's always going to be order pair involving t. So it's always going to be t and something else. And think of t as always your independent variable. So t is basically replacing your x. And whatever the other variable that you see is going to be your dependent variable, will be your y. Okay, so we're starting off at t equals 10. That's going to be our anchor there. So order pair is 10. We know at 10 minutes, 50 pounds of salt. So 10, 50. Okay, we can find the slope by involving the derivative, our differential equation. This is where we're going to get our slope. Typically, if there are multiple variables, I know we don't see it here, but usually multiple variables, we indicate a vertical line with the order pair that comes after it to indicate that we're inserting both pieces of information into the derivative. In this case, there's no t that shows up, so we only have to worry about a. So 6 minus 0.02 times 50. Use your calculator if you like. Cleans up to be 5. Okay, we have our order pair, we have our slope, and now we're going to work towards putting this into point slope form. All right, typically I know we're used to seeing point slope form in terms of x's and y's, but we're just going to make some slight adjustments so that we'll replace all of our x's with t and replace our y's with a. Okay, so I'm just going to update this with the specific information that we have for our equation. Okay, we have our equation, tangent line equation, but I'm going to solve for a to get it ready for this next part where I have to do linear approximation. So I'll just add the 50 over to the right side to get that a isolated. Okay, so now here comes the linear approximation portion. Insert 12 in for t. It's an approximation, so we'll do squiggly line here. 12 minus 10 is 2. 2 times 5 is 10. 10 plus 50, 60. All right, any question with part A? Part B is a little strange. It's not difficult, it's just, we just have to basically find A prime and show that the A prime is the same thing as dA dt. So let me skip part B, come back to it if we have time, okay? But let's skip to part C first. I want to go over the important parts, and if we have time, we can circle back to part B. Okay, so skip to part C here. So part C says the flow of solution into the vat is stopped and the solution is drained. The depth of solution in the vat is modeled by the function h that satisfies differential equation. So we have a differential equation where h of t is measured in meters, t in number of minutes, and since draining begins, k is our constant. If the depth of the solution is 16 meters at time t equals 0, so you have an order pair that we can use. Another one, 4 meters at time t equals 30. So we have two sets of order pairs that we can use to help us get to our general equation. So we're trying to get to h of t, but we're sitting at basically h prime, and we have a differential equation. We're going to have to solve the differential equation. So go through all the steps, separating the variables, taking the antiderivative, solve for c. But there's an additional step that's required because there's also that k that needs to be resolved. So that's why they give us two sets of order pairs, because we need to solve for c and solve for k when we get down to it. Okay, but first we're going to take the antiderivative to make our way up to h of t. Okay, so I'm always going to try to set up using a fraction equal to another fraction, so I can work towards cross multiplying first. Okay, so I'm forcing that one in the denominator so I can see exactly how the diagonals will be paired with each other. Okay, so cross multiply so that I can get my dH and my dt lined up. Now, typically with differential equations, I know we're used to seeing x's and y's where we're trying to get dy and y on the left, and dx and x on the right. But again, we need to be aware that sometimes you may not see your differential equation in terms of x's and y's, which is okay, because just have to understand that there's always going to be involving t if you don't see x and y. So there's always going to be t and something else. So treat t like you would x's, and treat h like you would y's. So that means we want all the y's on the left side, just like how we would group the y's, all the h's on the left. And just like how we would group x's on the right, we're going to group t's on the right side. Okay, so if I cross multiply, I can get the dH and dt in their right slots. So dH and dt are good to go. We don't have to move those anymore. They're in their right places. And now we can resolve the rest of the equation here. So what's out of place that needs to be moved? That root h. Good. That's the only thing, right? The k is okay on the right side because treat k like you would like a 3 or 5 or 8. We talked about how I want to leave the left side as bare and as minimal as possible. So only what's required on the left side do we need to have it there. Everything else we want to leave on the right side. So I'm just going to divide that root h over. Okay. Are we good up to this point here? Any questions? Now, I will stress how important it is with this step. This is the most important step of this process. And the reason that I say that is because if you were to look on the scoring guidelines for this, for basically all differential equations, they say 0 out of 5 points if students are not able to separate the variables. So if you can't separate the variables correctly, it doesn't matter if you do everything else correctly from this point forward, you're not going to earn any partial credit. So it's so important that we get to this point, because at least you have a chance of earning partial credit even if you make a mistake after this point, right? So that's why I say this is the most important step of the problem, because at least you have a chance of earning some points after this, even if you were to make some mistakes along the way after this point. Okay, so now we're going to take the integral of both sides. We still need to do a little bit of cleanup, but at least we have our variables separated. We can kind of look at each side independently and see what needs to be done. So that root h, we can't leave that in the denominator. And this is not a natural log integral, right? Natural log is only if it's h to the first power. But this is h to the 1/2, so we have to move it up and get it ready for power rule. So there's two things I'm going to do here. I'm going to convert this to be h to the 1/2, and I'm going to push it up to the top, which will change the exponent to h to the negative 1/2. And that will allow me to get this side ready for integral. Now the right side, remember, k is not a variable, right? So we can't just think in terms of, oh, this is k squared over 2, right? K is just a constant. So to help us remember that, I like to push it outside the integral and understand that I'm just taking the integral of 1 dt. All right, so power rule on both sides. We add 1 to the exponent. Adding 1 is same thing as plus 2 over 2. So we add 1 to the exponent divided by the exponent. That's power rule. One becomes t. The k is going to stay. Okay. Any questions here? I'm going to do a little bit of cleanup. A 1/2 in the denominator is same thing as having a 2 in the numerator. Okay, I'm going to reset, and I'm going to copy this down at the top of the column, next column, and work our way down. I'll keep it as 1/2. Now, typically, I would divide both sides by 2 because I like to keep the left side as bare, as minimal as possible. But I think in this case, though, I still have to solve for k. I still have to solve for c. I'm going to leave that 2 there because if I move that 2, I'm going to have to deal with 1/2, and it's just a little messier with the fractions. So eventually, I'll move the 2 over. But for now, there's no fractions here. It's a little bit cleaner. I'll leave that 2 alone, and I'm going to go back to the problem. Okay, it says the depth of the solution, 16 meters at time t equals 0, 4 meters at time t equals 30. What is h of t? So we have our general equation, but we do need to resolve the k and c, and then we can solve for h. So again, order pair is not in terms of x and y. Order pair is in terms of t and h. So I'm just going to gather some information here. So my first order pair, time t equals 0, 16 meters. So order pair 0, 16. Second order pair, at t equals 30, the depth is 4 meters. And I like to line this up because I know exactly what value is paired with which variable, so it just makes things clear and easier for me to, so I don't make a mistake in terms of putting the wrong value in for the wrong variable. Okay, so we have two order pairs here because we have two separate values to solve for. So now the question is, which order pair should we use first?
0, 16.
Okay. Okay, why the 0, 16 and not the 34?
Because it would give the negative kt a value. Like it wouldn't be 0, so you can find the constant easier.
Yeah. So this 0 is helpful in the sense that it will push away one variable quickly and allow us to solve for the other variable, right? If we plug in 30 and 4, this is not as ideal to begin with because we still have too many variables standing out there, but here we can resolve one variable quickly. We may not know exactly which variable is going to be solved first, but we know that 0 is going to be usually beneficial for us at the beginning. Okay, so we'll enter in 0 in for t, 16 in for h. So we see the k is that 0 is going to wipe out the k, which will give us that path to solve for c. Now that I have the c value, I'm going to go back to my equation and replace the 8 in for c, and I'll repeat the process by plugging in my second order pair. Now I can involve the second order pair and solve for k. Okay, 30 in for t, 4 in for h. Okay, we clean this up. 2 times 2 is 4. Subtract 4, divide by negative 30. Sorry, subtract 8, divide by negative 30. Do a little bit of reducing here, so k equals 2 over 15. And now I'm going to replace k in for where it needs to be inserted. So we solve for c, we solve for k. The only thing left to do now is to find a way to get that h by itself. So 2 things I'm going to do. I'm going to divide everything by 2. Then I'll square both sides to handle that square root. Dividing by 2 is the same thing as multiplying by 1/2. So distribute the 1/2 through. One-half times negative 2 over 15 becomes just negative 1 over 15 t. Distribute this through as well. 1/2 times 8 is just 4. And if you want, you can leave it in this form, or you can understand that the 1/2 is really, we need a square on both sides, or if you want to think of it in terms of square root of h, we can also have that square both sides. Either way, we're going to be able to get that square root resolved. And there's our h. Okay, any questions? Okay, give you guys a minute and then we'll look at number 2. Okay, back page. Okay, so on Saturday before Mother's Day, a drugstore has a large selection of greeting cards for sale. Between the hours of 0 and 10, number of cards left on the shelf at time t hours is changing at a rate of m prime, measured in cards per hour. Function m is twice differentiable. Just means that it's a smooth curve. M of 7 is 44, so that just tells us that 7 hours in, there's 44 cards left on the greeting card shelf. So part A says approximate m double prime of 6. We know that we have order pairs given in terms of m prime, so we know m double prime is the derivative of that, but we don't have an equation that can allow us to find the exact derivative. So the next best thing is using slope to approximate the rate of change. So it says approximate, but we want to try to achieve the most accurate approximation. And that means we want to choose order pairs that's closest to the source that we're talking about. So we're talking about t equals 6. So the closest order pairs that we can choose is 5 and 7. The closer we get, the more accuracy we're going to be able to achieve. So change in m prime over change in time. Okay, we just pull order pairs from our table here. So negative 12 minus negative 14. Two negatives ends up canceling out. We're left with negative 12 plus 14, so we end up with 2 over 2, which is 1 card per hour, 1 card per hour squared. So using correct units, interpret the meaning of m double prime of 6 in the context of this problem. So something that's I want you guys to be able to do is understanding how to put these rates of change into words. So especially with second derivative, I think sometimes we just need to understand how that process works. So we always are looking at the sign to determine whether we want to say that this rate is increasing or this rate is decreasing. So that's always the path you want to go down, especially if you want to be able to word it in a way that will earn you full credit. I think the tendency potentially is that we see second derivative and we want to just think in terms of acceleration because that's the first thing that comes to mind for particle motion. But this is not a particle motion problem, so we're not going to be able to utilize some. We can't call something acceleration, at least not for this problem. So what we can say though is that this rate is increasing at 1 car per hour squared. Okay, so we'll say this. Okay, so whether it's positive or negative is going to allow us to say whether m prime is increasing or whether m prime is decreasing. Right? This is describing the rate of change of m prime because we're sitting at m double prime. Okay, so I want you guys to be able to just to be able to understand how to word it in the way that will earn you credit. Okay, part C, we're back to tangent line equation. So very similar to what we did on the previous page. Find order pair, find slope, point slope form, and then linear approximation. Again, instead of x and y, we have a different set of order pair in terms, now it's in terms of t and m. So we know that order pair t is 7, so we look at what's given to us, order pair 7, 44. Slope comes from m prime. We have a table of values in terms of m prime, so we can just say m prime of 7 is equal to negative 12. Okay, so there's our slope. Typically, point slope form is in terms of x's and y, but we just have to make the adjustment for our specific variable. T will replace x, m will replace y. So we have our tangent line equation, but we're going to solve for m to get it ready for our linear approximation step. I'll just add the 44 over to the right side. Okay, so here comes the linear approximation step. Okay, so plug 9 in for t. Okay, I'll do a squiggly line here to indicate some approximation. Negative 12 times 2 is negative 24. Negative 24 plus 44. M is in terms of cards, so using linear approximation, we can approximate there's going to be 20 cards remaining on the shelf 9 hours in. Okay, questions so far up to part C? All right, part D. Is there a time C between 0 and 7 such that m double prime is equal to 0? So we have table of values in terms of m prime. M double prime equals 0 is basically saying, can we guarantee that somewhere along the m prime graph that there's a slope 0 that exists on the m prime graph? Right. That's basically what we're getting at here. So if I'm trying to guarantee a slope 0 on the m prime graph, that's going to be Rolle's theorem, right? We'll see if Rolle's theorem applies. That means we're looking specifically for order pairs that are exactly the same. And if I go down my chart here, I do see a pair of matching order pairs. So that's a good sign because we know that the graph may be at -12, but it's going to dip down, maybe -14, maybe lower, but we know it's going to dip down, but it's going to have to come back up. And as it comes back up, there's going to be a slope 0 that's going to be guaranteed because we already know it's a smooth curve, right? So Rolle's theorem will apply. We just have to state our reasoning out. Okay, so I'm going to have us write this down here. Okay, so Rolle's theorem, because all of our conditions have been met. They tell us it's differentiable, so if anytime they say it's differentiable, we can just assume that continuity is also true. So we know our m prime is continuous on the closed interval. We know m prime is differentiable on the open interval. We have endpoints are two order pairs that are exactly the same. M prime and M7 are both equal to -12. So then by Rolle's theorem, there must be a value of C, at least one value of C in between 4 and 7, where the slope must be equal to 0. You don't have to draw the graph. I just want to kind of show you visually that we can guarantee a slope 0, right? I have order pair at 4, -12, and order pair at 4, -7. It's going to have to come down, come back up. There must be a slope 0, and that's where I know m double prime of t must be equal to 0 somewhere along that interval. Okay, questions there? Part F, it says use the right Riemann sum with 4 subintervals to estimate the integral from 0 to 7 of m prime. Well, we have the m prime table in front of us, so we just have to go through and do width and height for each component. So we'll go to our table, identify the 4 subintervals, and then subtract each subinterval t hours so that we can find the width. And then we just pair width and height to create areas of 4 rectangles. Now, notice that there's no absolute value in what they're asking for us to find, so we're going to have to hold on to all these negative values. All right, so don't change the sign of these. Okay, so width times height, width times height, width times height. And we know that after we take the integral of m prime, it's going to convert our units from cars per hour to just cards. Okay, so width times height, 4 sets of rectangles.
What's the-
Total that up, and we get negative 84. Now, it seems kind of strange for us to say negative 84 cards, but what this indicates to us is that over the 7-hour period, 84 cards are going to be leaving the shelf. So typically what that means is 84 cards sold in that 7-hour period. I know the problem doesn't ask us to provide units or even justify our answer, but I think it's always good to think about, what our answer means. If you ever have to justify it, you know how to how to phrase it in a way that will earn you credit. Okay, any questions with F? All right, let's look at part G. All right, it says evaluate the depth integral, show calculations that lead to your answer. Anytime you see any sort of messiness in function notation and integrals involved, you know it's going to be U substitution, right? So we have to resolve this because there's most likely going to be a coefficient that we need to keep track of. So we'll target what's inside the parentheses and the dt as well. All right, du dt. Solve for dt. Make our substitutions. Clean this up a little bit. I'm going to push that -3 out as -1/3. And now we just have to recognize that we don't apply power rule or any type of integral rule. We just know that this is really first theorem, right? We know second derivative after we go through integral process is going to make its way up to m prime. But it's good that we went through U substitution. Otherwise, we wouldn't know that there is a -1/3 that needs to be part of our answer. Okay, so we lose the integral because we applied that process, and now we're up a level to m prime. Now, once we're here, we still got to involve the bounds, but right now there's a mismatch in variables. So I think the cleanest, fastest way is let's just bring the u back in terms of t, and that way we can just rely on the original bounds. Okay. I had us before do a lot of change of variable, and that's just to prepare you guys for problems on multiple choice section where they're forcing you to go through change of variable to see if you understand that process. But if it's a free response problem, typically we want to move as fast as we can. So the most efficient way usually is just bring this back in terms of t and then use the original bounds. Okay, so now that I'm back with my original variable, I can pair that up with 0 and 1. Upper bound gets evaluated first. Minus, then the result from the lower bound. Seven minus 3 is 4. Okay. We go to our table of values. We have a table of values in terms of m prime. So m prime of 4 is just 12. M prime of 7, sorry, m prime of 4 is -12. M prime of 7 is going to be -12 as well. They're both -12s. Right, I'm just pulling these from my table here. So I have 4 minus 4, and that's just going to be 0. Okay, I have a few minutes remaining. I'd like to do part B that I skipped over from before. So if you can go back to the first page, let's just do that one quickly here. Okay, you guys good? All right. Let's get back to this. Okay, part B says that show that A of t satisfies differential equation. So we should have to understand that this is basically the derivative version of this, right? So I'm going to find A prime, and we'll see if I can get A prime to make my way to be equal to this. Okay. Because A prime and dA dt are the same, they're just different ways of writing the same, different forms of the same equation. Okay, so if I want to find, let's see, let's start with A of t here. If I want to find A prime, I need to find the derivative. To find the derivative, I know that there's a specific rule for e to the u, right? So as a reminder, the rule for e to the u is just e to the u times u prime. So if I follow that rule, I know the 300 is just going to go away. That's just going to be 0. Coefficient is going to stay. So e to the u becomes e to the u times u prime. So what's the derivative of my exponent?
0.2.
Close.
Negative.
Yeah, -0.2. All right, so if I clean this up, hopefully after I clean this up, I can see maybe see if it'll look like this. But I'm just going to multiply the -250 and -0.02 together just to see if I can make some progress instead of in terms of matching them together. So in my calculator, -250 times -0.02. That ends up giving me 5. So if I look, this is not quite matching up with my dA dt. So maybe I can play around with this form to make it match this. So let's see. We know dA dt is 6 minus 0.02a. So is there any progress that I can make to hopefully get these two to look like each other?
Maybe natural log function.
We don't have to do that messy of a step. Maybe we can just do something with this a here. What's a equal to?
300 minus.
Right.
The original function.
Yeah, the original function, right? Let's just see if I plug in the original function, maybe it'll make its way to look like this, right? Which is basically playing around with two different forms and working to the point where they're hopefully equal to each other. So if I distribute the negative 0.02 through, let's see where that brings us. 300 times negative 0.02 gives us 6. Two negatives become positive. 0.02 times 250 gives me 5. And now, once the 6's cancel out, we now have confirmation that these are the same, right? So one equation, we found the derivative. The other equation, we just made a substitution and just proved that they're the same. All right, so this afternoon, 3:30, I'll do a help session going over the homework for tonight as well as homework from yesterday. I'll record it, but understand that your test is Tuesday, so if you want to work ahead just to kind of get some additional practice before we go through it in class. Yeah, use the weekend if you need to start reviewing and start practicing for Tuesday's test material. All right, thanks everyone. Hope you guys have a great day. Or a great weekend. See you Monday.